Okay, so now we're getting into absolute value inequalities. We've learned how to do absolute value equations. And before we go through the rules of solving absolute value inequalities, I wanted you to look at this one example. And it says, which of the following pairs of inequality is equivalent to the absolute value of x is greater than 4? And so in front of you, A is x is greater than -4 and x is less than 4. Part B says x is less than -4 and x is less than 4. C says x is greater than -4 or x is greater than 4. And part D says x is less than -4 or x is greater than 4. So take a moment, see if you can figure out which is true for that inequality. And then I'll turn back on the video. I'm going to pause for a second. Okay, so you had a little bit of time to look at this and determine which one you thought was correct. And as a class, you guys had shared with me what you had gotten, and let's just talk through this. And so we have the absolute value of x is greater than 4. Recall, first of all, when we were looking at the absolute value of x, let's say that this was equal to 4. There was two values that we saw with the absolute value equation that would set our the equation. We could solve the variable and get to a different answers, possibly. We couldn't have the absolute value of x equal a negative number because that's impossible. But when we had dropped the absolute value, right, +4, absolute value of +4 gives us 4, and the absolute value of -4 gives us 4. Excuse me. So let's think about it this way. I don't know if you guys remember when you were solving inequalities before in a different algebra class. Sometimes we looked at what we call these critical numbers. And in our case, in the absolute value, it's what sets the absolute value equal to 0. And we tested values on each side of a critical number. So for instance, if I tested any number to the left of x equals -4, any number smaller, so choose anything less than -4. So how about -5? We want to see if we plug it back into this statement, if it's true or not. So if we plug in -5, is this to the absolute value, is this greater than 4? Yeah, well, the absolute value of -5 is 5, and 5 is greater than 4. So this is a true statement. And so anything that we would have chosen to the left of -4, if we plugged it into that inequality, it would have been true. So choose something that's in between -4 and 4. So I like to choose 0 if it's inside an interval, just because it's usually the easiest. And so if we look at the absolute value of 0, we want to know, is that greater than 4? 0 greater than 4? That's false. So nothing that we would have chosen in between -4 and 4, not including those values, would have given us a false statement. Where if we chose anything bigger than 4, so how about 5? Check it, and we can see that the absolute value of 5 is greater than 4. So this is true. So everything to the right of 4. So it really depends on if we include that, what I call critical number, -4, 4, depends on if we have the equal to part or not to the inequality. We don't have the equal to, so we're not going to include that point. And so it's everything bigger than 4, but it's also everything which is less than -4. So just kind of the terminology and or depends about sets and what they mean. And means that both sets have to share the same thing. It's an intersection of two sets. Or means a union of two sets. So it's what's in one set is a solution, or you can take what's in the other set that's also part of the solution. So this is an or statement. And so that would be this B piece. So X is going to have to be less than -4, or X has to be greater than -4. And so if you had chosen B, it's almost identical. It's just that difference of the word and or. If you looked at and, well, if you look at my graph and look at those two sets, there's nothing that they share in common. So if that was an and statement, there would have been no solution. So let's kind of do the same idea. If we had an absolute value of X, which was less than some, and let's say positive number. So let's just look at an example. So let's say we had the absolute value of X. How about we'll just use 4 still, is less than 4. So same sort of idea. If I think about what values set this equal, what values of X, absolute value of X would give me back +4. That would be 4 and -4 again. And if we went through this and we checked a number in the interval, so the left of -4, if we chose -5, and if we plugged it in to see if that was true or false. So if we plugged the absolute value of -5, is that less than 4? Well, that would give me 5 is less than 4, which is false. Where if we had chosen X equals 0 in this case, the number in between, a number in between -4 or 4, any number there, and we plugged it in, the absolute value of 0, is that less than 4? Yeah, 0 is less than 4. So this is true. So I'm going to shade everything in between -4 and 4. And then let's try anything bigger than 4. So again, let's maybe 5. So is the absolute value of 5, is that less than 4? No, 5 is not less than 4. This is false. Okay, so I wanted that blue, but that's okay. Again, we are not going to include in this case the bounds of that inequality. We're not going to include -4 or 4 because of the equal to part is not on the inequality. So we're going to put parentheses on the 4 and -4. So notice this is another way to write this. This is like a compound inequality. This is like the same thing as saying -4 is less than X is less than 4. Where when we had it as a greater than sign, when we drop the absolute value symbol, we set it less than the negative of what we had on our absolute value inequality. And we dropped the absolute value and kept it the same direction, greater than 4. So less than the negative and greater than the positive. And so that brings us to the rules of how to solve inequalities in these theorems. So if you have a less than or equal to, and we have the absolute value of some algebraic expression is less than A, then it's equivalent to sandwiching it. So -A is less than U is less than A. If it has the equal to part, it's almost equivalent. We drop the absolute value and it's sandwiching it in between -A is less than or equal to U is less than or equal to A. So another way to say this is U is greater than -A and U is less than A. I tend to like to sandwich it, but it's the same thing. If your inequality was greater than, we saw that to drop the absolute value, you're going to set it less than the negative of the other side, or you're going to have it greater than A. Equal sign, almost identical with the inequality. You just add it to the inequality piece. So let me pull some problems. Okay, so our first example, we have -3, absolute value. Inside the absolute value is 2x minus 5, and the absolute value is greater than or equal to -24. When we're solving absolute value inequalities, first thing you got to do is isolate that absolute value, just like when we had the equal sign. And so we don't want that -3 in front of that absolute value. And so we can get rid of that -3, right, by dividing both sides by -3. But we are dealing with inequalities. So we know if we're dividing or multiplying by a negative, that flips our inequality sign. So right now I would have then the absolute value of 2x minus 5 is now less than or equal to, and dividing -21 by -3, that gives me back +7. Okay, so now I determine which direction or how I'm going to drop these absolute value. Less than or equal to, we sandwich it. So this would be -7 is less than or equal to what's inside the inequality, 2x minus 5, is less than or equal to 7. So I'm going to just isolate x in between those -7 and 7. And I can do that by doing everything, the same thing on each side of the inequality. So if I add 5 in the middle, I have to add it on the left and the right. So I get -2 plus 5, I'm sorry, -7 plus 5, which is -2, is less than or equal to 2x, which is less than or equal to 7 plus 5 is 12. We're dividing by a positive number, so everything is okay with the direction of our inequality. And so let's divide everything through by 2. And so -2 over 2 is -1, is less than or equal to x, is less than or equal to 12 divided by 2 is 6. So a lot of these, you'll be asked to graph the solution and put your answer in interval notation. So we're looking at everything in between and including -1 and 6. So shade everything in between. And since we're including because of the equal to part on the inequality, we're going to put brackets on that -1 and the 6. And interval notation, we'd have bracket -1 comma 6. So all x values in between and including -1 and 6. So the example now we have in front of us is 3 minus the absolute value of x plus 1 is less than 1/2. So again, we want to isolate this absolute value before we can drop it. And so I noticed that I need to get that 3 on the other side, and I need to get rid of the negative in front of the absolute value. I don't really like that I have a fraction, and I can clear that, but I don't have to. I'm going to clear it. For now, I know I'm going to get it back in a minute, but let's multiply everything through by 2. So I'd have this 2 times the 3, which gives me 6, minus this 2 times this absolute value. So it's outside the absolute value. So 2 times the absolute value of x plus 1 is less than 1. So let's subtract 6 on both sides. So this would give me -2, absolute value of x plus 1, and absolute value is less than 1 minus 6 is -5. Okay, so now I actually have to deal with a fraction for a second at least. And so we need to get rid of the -2 in front of the absolute value. So we can divide by -2. but we're dividing by a negative, so I know that that's going to flip my inequality. So now we have a greater than instead of a less than. So we have the absolute value of x plus 1. That is greater than positive 5/2. So now my inequality has changed and I have absolute value isolated. So we can drop this. And if it's a greater than sign, it's two separate inequalities. It's x plus 1 is greater than itself, 5/2, or so it can be part of this solution set, or it could be part of the solution set x plus 1 is less than the negative of 5/2. Okay, so let's get x by itself. I can clear the fractions, but I think it's easier if I just think of this as getting a common denominator. So when I subtract 1 on both sides, let's think of it as that 1 as -2/2. So we just have a common denominator. So I get x is greater than 3/2 minus 2/2. Sorry, 5/2 minus 2/2 is 3/2. So same idea here. When we're subtracting 1 on both sides, let's write it with a common denominator, -2/2. So in this case, we get x is less than, well, -5/2 minus 2/2 is -7/2. So our solution is everything that's less than -7/2, which is the same thing as -3 1/2. So everything to the left of that, and not including because it's just less than. And then everything that's greater than 3/2. So 3/2, same thing as 1 1/2. And it's everything greater than that. So everything to the right of that, not including the end value, so parentheses. So from the graph, it's easy to see, hopefully it's easy to see what the interval notation will be. So -infinity to -7/2, parentheses, union, so plus the set, parentheses, 3/2 to infinity. So I think really the hardest part of this is to remember when you're dropping the absolute value, which direction it's going to be or how to set it up. But if you ever forget, then go just to a simple example like we had done. If I look at the absolute value of x greater than 4 or absolute value of x less than 4, and think about it logically that way by trying some points, and then you can kind of figure out which way the inequality would have to be when you drop it. Or you can memorize it, either way. So I'm actually going to take a moment and have you guys try a problem. So let's have you try it. And the problem I want you to try is the absolute value. We're going to have a fraction. In the numerator, we have 2x minus 3. In the denominator of that fraction, we have 2. Okay, so that's one fraction. And then in between that fraction, we have plus, and then we have another fraction. And the other fraction is just 1/3. That's in our absolute value, and this is greater than 1. So take a moment and try that. I'm going to pause the video. If you're watching the video and not in the lecture live, then pause the video, try it, and then start the video again. Okay, so let me actually go back to my screen. You had a chance to work on it, and now let's walk through and go through it. And so I'm just going to I've already done it on my page. I'm just going to scroll it up and we'll walk through each step. Right now we have the inequality by itself. I'm sorry, the absolute value by itself. And so we can drop the inequality. It's a greater than sign. So to me, that is telling me that To drop it, I'm setting what's inside the absolute value less than the negative of the other side, so -1, and what's inside the inequality greater than, in this case, 1. Inside the absolute value, inside the absolute value, we have fractions. So I found the LCD, and in both cases it's 6, and distribute 6 to both sides of the inequality. I did do them differently, but they're next to each other side by side. So let's just kind of walk through them each. So distributing the LCD, you didn't have to do that, but that just gets rid of the fractions. And so distributing the 6 to the first fraction, 2 goes into 6 3 times. So I'm having a 3 left in front of that parentheses, the numerator 2x minus 3. Distributing the 6 to the 1/3, 3 goes into 6 twice. So +2 is less than 6 times -1, so -6. Same sort of idea on the right inequality. Distribute that 6, we get the identical what we had gotten on the other one, except that this is greater than +6. So we have to simplify each side of the inequality down. So we need to distribute that 3 inside the parentheses. And so if you do that, you get 6x minus 9 plus 2 is less than -6. On the second inequality, we get 6x minus 9 plus 2 is greater than 6. Combine like terms. So we can combine -9 plus 2 on both sides, or each inequality. So each inequality, we have 6x minus 7. One is less than -6, and then 6x minus 7, the other one's greater than 6. So we need to add 7 to both sides to get the term of x by itself. So if you add 7 to -6, you get 1. So 6x is less than 1. And if we add 7 to +6, we get 13. So we get 6x is greater than 13. Divide each inequality by 6. It's a positive number, so inequalities stay the same direction. So we get x is less than 1/6 and x is greater than 13/6. And so I wrote it with our graphing our solution set and putting it in interval notation. So -infinity up to 1/6, parentheses, that's all shaded. And 13/6 shading to the right of that to infinity. Okay. So if you didn't get it correct, hopefully you found out where your error was and what you had done wrong. And if you had tried it and got stuck, hopefully walking through this clarified where you were getting stuck and what to do. So let me ask if there's any questions. Let me pause the video and I'll come back if there were any and explain what it was. So just a couple different questions or comments. So in my case, once I dropped my absolute value signs, I cleared my fractions and we didn't have to do that. So if you had done this process like in this step, instead of clearing, subtracting 1/3 on both sides of the inequality, you would have gotten the same result at the end. The other question, just to clarify, this is my -infinity symbol right here. And this is my positive infinity symbol. And then interval notation. So this is the rest of 1.6, which are solving absolute value equations and absolute value inequalities. And this video is just absolute value inequalities. You'd have to watch another video from the previous lecture to find out on how to solve absolute value equations. So we're going to stop for now and take a break, and then we'll come back and we will look at applications, the last section in this textbook that we're using, which is application 1.7.